This particular course and lecture is meant for practicing students and the occasional serious amateur hacker who enjoys making their own small products and so on. I am sure several of you would have come across the necessity to package a small electronic circuit that you have. The whole thing is addressed towards that. As my hope, I think I should put your signal this thing here. As my this thing shows here, I am from the Indian Institute of Science, Bangalore, India. So, this whole lecture series has 60 sessions lasting a little over maybe 30 or 32 hours. There are 4 videos which are shot on our premises. And then I would like to acknowledge the immense help taken from my colleagues who have worked on this for a long time. This course was being run in the Indian Institute of Science Center for Electronic Design and Technology for over 35 years. It started with something and eventually we have moved on now. So, you see here, I will start with the very first slide without too much of ado. Sir, if you can show me, we have this issue of what is a product, what is industrial design, and then what is design, and then finally what constitutes what. Over the years things have improved tremendously. So, you see here design seems to integrate mainly usability of the product, how well the product can be used by the intended user. So, in this case, first thing that attracts your attention when you look at any product is probably aesthetic appeal, how it looks, it goes. We cannot ignore it, whether you talk about a mobile, whether you talk about a home, whether you talk about your own any other objects that you own, aesthetic appeal. And then once you touch it, suddenly you find out the ergonomics, how well it can be handled. Some people hold a mobile in their hand and all that, and when you go to a shop, at least in these parts of the world, they will give you a mobile which is a mock-up. It behaves, it feels, it weighs about the same time as a thing. So, you choose between 1 or 2 models, then you come to the functionality of it. Functionality is how well you get all the various things and so on, and finally ultimately the thing seems to be about how well the product can be marketed. Marketing, again, it is not about selling. Marketing is all about how you get the feedback from the user. A lot of times user is not ready for the product yet, but then how do you work in the near future, and then how do you have a visionary future. From here, part of this has been taken from standard textbooks. So, you see here the core benefit we have, and finally on top of it is an actual product which has tangible and intangible things. Sorry. So, it has this tangible and intangible benefits and so on. There is an augmented product which involves all the finance and all that. So, you have finally products which are sold. So, very nice to see such things. And then I probably need to take a little, I do not know whether I can call it a break or whatever it is. Industrial design as defined by our patent office several places is about anything which you can file and you can claim as a different thing, is a termed as any physical occurrence of an object is considered a new industrial design. It is not about the industrial design as a service, industrial design as a philosophy, industrial design as call for changing this thing and all that. So, if you see, I am sorry for the small letters, a representation is exact of the article on which the design has been applied, identifying, then How? If the ornamental in an article likely be confused with a trademark, suggest any this thing and so on. So, I suggest you go to a place called the WIPO and also our own patent offices. WIPO and patent offices have specifically made definitions of what it is. Okay? It is not mine, not all mine. In the actual what I call presentation, I have spent a little more time on this and then you can understand. From the patent office, industrial design is something else, saying already something which can be producible and all, which is very different from the original first article that is there. So, I suggest you read it. In the 60 sessions which are uploaded, I expect that these things will become little clearer. So, the next slide, have a look at it, just keep looking at it. Lot of pigeons, and then you see what has started here. Oh, suddenly you have seen what started as a very simple object. Now you see it is actually, there is a huge beehive of activity whenever it comes to these things. You can't pigeonhole the various aspects of it. Just let the slideshow run. I will come back, I will get back to you. Have a look at all these things. So, you see here what started as pigeonhole, suddenly as more and more activities have come, there is no place for the pigeons. In fact, if I go back here again, you noticed here in the left top corner, no, there is an extra pigeon, the face is not visible. It is a stupid allegory, excuse me for the word stupid, but I am meaning it looks okay allegory. In some conditions it works, saying the activities are equally defined, clearly defined, and they can be run one after the other, which is probably once upon a time things were. But if you have to take a modern product like a mobile phone or including anything what you see, things are very, very complicated. They seem to be getting done together, and then all of them have an emotional component in it, and how they are placed in your mind seems to be equally important as this. So, it is a behavior of activity, it is not as if, no, it is just an activity. So, the next slide shows me these what do you call so many large amount of things which goes into the manufacture of a product. What looks like a very simple product is no longer something, you can't call it an electronic product, and then secondly, things are getting what you call more and more complicated. Even if you have to take a very routine thing, you see at the right side you have a wall clock made as a concept by one of our students. I have this wall clock which has anything, you see it looks very different from the other things. This was done by my design student, and obviously, I mean, she's somewhere, I don't even know where it is. But however, in your what do you call it, home or workshop or anything, it is very easy for you to fabricate the sheet metal which I have shown down, and at the left we have something which could be done in a plastic or anything. You see here, slowly as we come, we are slowly getting to the concept of three important things a package needs to deal with. One is there is the environment outside, there are thermal issues to be solved, and there is interconnection between the inside of the enclosure and the external world. So, the dotted line which is there around is typically is supposed to represent our activity. To make it dust proof, we can seal it, and then what will happen to the heat? So, obviously, heat will have a problem, you can't take it out. If you make holes, you are blowing all the dust in. As if this were not enough, how do you take out the connections, and how do you ensure, while the physical reality is all this dust and moisture and all that, what about the electrical things like EMI and radiation otherwise, and I know these days people call about non-ionizing and ionizing radiation and all, how it gets affected. It is an older thing. I have taken what you call extensive, I have depended on extensively on what is available in the free domain. You see all those aluminum various things, there is a fan there, and then there are what you call gold colored some pipes, then so on. Things have become complicated. What looks like a very simple PC or what you call a laptop is not as easy as it is. It has to do everything. And you see this is what our group has done. There is a drive for a electric vehicle. Left side, that was what was we could finally finalize the design and all that, and then eventually it ended up in this beautiful enclosure. One of the first things you will see in this enclosure is there are special connectors here. You have seen this? These connectors get the power in and send the power out. The ones with the pins or the plug configuration is the one that feeds the motor, that blue colored device, and this red one is the one where you get the power from power into it. And then at the left side we have a multi-pole connector, multi-way connector, which ensures that all the signals and all are taken care of. My colleagues in the field, they have been working on agricultural what do you call sensor operations. You see those two what do you call dedicated people up the thing. It's a wooden pole, something which we could erect on the top, and then they have put various antennas, they have made enclosures, and you see right side top, this enclosure is the one that they have made. We can seal it here, then what about the actual sensor, how does it get sealed, and still it should be contact with the moisture, the thing around and all that, This lecture series is a little about it, but and then we have this stuff about IP protection or index of protection as per IEC 60529. What do these things mean? Evaluation of classifications and so on. How do you do it? I try to explain a little in these lectures. While that is real and that is something related to what do you say technical, there is something which is user related in this. Another design student made us all this, some biomedical equipment which should be easily this, that and all that and identifiable and so on. There is a small list of all the lectures that have been included in this. The total 30 hours, and then thing has been split into 60 sessions. Enclosure design for electronics equipment runs is a little one of the longer ones. That is the first lecture. Part of these things what you have seen are from there. Then you have aspects and features that are non-electrical and essential to electronic product realization. Electronics people still the field has become so specialized they must do tremendous analysis and optimization. It's not left that much to simple guesswork or gut feeling. So, as part of this non-electrical things are all those features which I was talking about, saying how do you make sure it is very much presentable like that. So, next one, in a small electronic equipment, how do you do the simple design? You should go through the lecture in patience, then design as applied to small electronics products and projects. So, I tried to show something. Next picture actually comes to something which we we enjoy, but not if it is your main work. I am sure several engineering students won't like drawing, and they would have tried to do other thing, but then drawing is essential for communication. So, we have a highly developed engineering language on how to do representation. If you are electronics people, you know schematics, you know presentation in a schematic, what represents what and how it is. And in the case of mechanical, we also have such things, saying how are the 3-view engineering drawings are prepared and so on like that. However, in the case of products, something else comes into place. Somehow we need to learn sketching to quickly communicate our ideas to everybody, and as we communicate and as we sketch, we improve our own understanding of the product. And at this point, fortunately on our premises we had some trained graphics designers, but then I have relied heavily and tried to retrieve things from the internet, from various blogs and so on. So, one of those things I have included it, and then I would like to acknowledge, it is all acknowledged in the lecture properly. You should understand how difficult it is to make it and all the trouble they have gone in putting it, and you must try it out yourself. Next comes to having done the sketching and all that, invariably we need to make a quick model. We are all familiar with this model making when it comes to architectural models, and in fact we are amazed at it. When you say an architectural model, you in fact you get a bird's eye view of the whole world all around. That bird's eye view seems to be impressed. I have changed. No, it's recorded online only. I thought this is how it is. Other shirt instead of hats, no. This is my normal shirts which I wear. That was intentional. I wanted to show that I am from ISC, and then this is what is my normal wear. In all my lectures I appear like this. So, I noticed that all these architectural models and all that, they are made in a particular way, they are very, very impressive. And in fact, these days it has gone to the next level, saying a lot of them are renderings, and the renderings have been made so convincing and nice, and point of view has been arranged well. Difficult for you to believe that it is not a real place. That is how they first make the sale. It is again one more thing, unless you have demand, you can't start the construction. Unless there is something, some idea which we need to know, nobody will pick up parts of the project. So, you are most likely to come into contact with these things there. And then if you are one of those curious people and you keep looking for products all around, and if you have gone to the CES, the convention which is held in, convention which is held announcing new products, suddenly you will discover there is a new world out there and it is ready. Same thing which happens with automobile shows, and it is a matter of time from the time you see the concept and the actual availability for you getting shorter and shorter. Some of them are available in the next year, maybe within 12 months, and somebody has worked on it earlier. Some of them takes a little longer, we call it futuristic. So, you need to find out how to make a quick model and stuff in plastic, and then I try to make it relatively simple and easy. So that, but the key to it is you must attempt it and make it yourself. and we don't, there's no way of my sending you a kit, and this is not the full thing. You need to practice it on your own and then try to make things. Having done this, we come back to some very important thing in the case of all our in reality. Reality is very rarely people start for usual small projects and maybe a few hundred enclosures. It is unlikely everybody tries to start from the beginning and make a new full enclosure for it. So, anything you can think of is probably off the shelf, it is available. You need to go around, look for the catalogs, and then after the e-commerce and what do you call this online thing has started, things may look a little expensive, but anything you can think of, it's already available with more features when you thought were necessary. And then related to that is the documentation. How do you read the documents that they have presented there? How do you select one of them? At this point, it's a what do you call? I won't call it a trial and error. I will say it as learning experience. You probably start with a slightly bigger volume than required. After that, you try to after you make the first unit, then you once again go back to the what do you call the catalogs and select things. We come to very interesting things here. You have seen this. There is something about safety. So we over here in these parts, I think we believe there's some benefactor protecting us out there. So we are a little lax in these things. So I have shown you examples of things which are not very safe local things, and eventually everything goes back to this index of protection class that has been started from the IEC and DIN norms. And parallelly, that American what do you call Electrical Manufacturers Association had themselves much before these electronics thing came, they went about standardizing. So you have a NEMA classes, and then there is a testing. So this testing, well, I have seen it in reality. You probably have to look up the videos online to see how harsh things can be. Then on our premises, we have a few of these sealed enclosures which I have been using for some equipment. Wanted to show you. This is the one what I was talking to you, in which we tend to believe it's all right, somebody will take care of us. This public utility, various things are kept outside, not out of vandalism, they are not maintained well. So I have taken pictures of those things which I feel now they are valid for anybody. And slowly we come to a borderline area called EMI ceiling. The effects are felt electrically, but the handling is by the mechanical and fabrication people. So this EMI ceiling is critical. Then after that, something about a little more details about the sealed enclosures. Then how do you make gasketing practice, gasketing basics. These two, basics and practice, is actually taken from various sources. It's readable if you are in that area. If you are not in that, not particularly interested in it, you need not pay too much attention. Starting from 40th lecture, you see that off the shelf there are various enclosures made out of metal. And then the 41 lecture now is about calling it a box, understanding boxes and documentation. So at least here you can't think out of the box, you can think about the box. And then tremendous documentation is available, and then you need to see how well you can understand something for you. Very much related to it is, that is how the word aluminum has been used there. Very much related to this is enclosures which have a heat sink built into it. And then how do you detail the insides of those things, how do you read the documentation once more. If you go out and see all the things which you see all over the place, now these days you have the GSM and CDMA boxes and all that, nice, they just work. I have no clue about the electronics because they say it's too complicated, but at least the heat sinks and those things are understandable. Something which I started in the one of the earlier slides about, I have covered both of the things if you see. First of all, no, how to handle the heat business, then about the other functional aspects. We come to interconnection aspects of it. In this case, is particularly about how to choose a proper connector such that your enclosure works properly. It will never fail. This has been directly taken from trade catalogs and whatever they have supplied, and at the time of retrieval, that is around May 2017, these were current, but I suggest you go back and see what else is available. Some of them look archaic and ancient, but the things are very valid, like current carrying capacity, number of this and orientation and so on like that. Basic USB, it is a standard, and then we have A and B, and then I have a mini and a micro USB, and then we have a host, and then we have the usual plug-in and all that. Standards are fixed, and slowly things are getting evolved as they become smaller and smaller. These things have not changed. Similarly, if you talk about the N type of connector, or in the case of power things, these things have not changed. They are still there and are likely to continue. So, that lecture was about the connectors. The next lecture, if you see here, this is something which has been a convenience and both a blessing and made things too easy. So, we have this computer aided design in layout. So, in this case again I would like to stress that we have computer aided design from the analytical optimization point of view, computer aided design from the way of making manufacturing easy. How do you make drawings, and for us to understand the various things is about how to lay out all the components and parts and all these things. So, over your professional career, if you can build up a library, instead of going and bringing the parts, you just bring the library and arrange things. While it has been done extremely well in EDA, design, electronic design automation, it is not that easily done at this level. Again, architecture, you have pipe and drawings are standardized, everything, structural elements are standardized. In the case of equipment, we still have, it is a prerogative of the designer. So, this point, no, I do not know how to stress types of CAD. There are too many out there. Whatever I am familiar with, I have used it. Over here in Bangalore, two of the things about the Dassault and Siemens I have an understanding with the colleges. So, either SolidWorks or Solid Edge is taught by default, and I am sure a lot of Pro-E people and CATIA people and so many of you are there, and then good old Autodesk products are out there. All of them are equally welcome, and I am not endorsing one or the other. And if you have the patience, you can go download limited user, limited save type of things, use it short time, and in my considered opinion, buy one. Buy anything is as good as you buy it. So, coming back to our list of the slides here, you see that how to make CAD equipment. It looks too much of it, no, but I have kept on trying to give as many examples as possible. CAD sample example, layout, integrating products with CAD, product detailing, and comes to CAD physical models, saying just like you are able to use your EDA tools for having a schematic, run a beautiful simulation, that is you can have a mixed mode analog digital simulation at any frequency you like, and eventually after you make a physical printed wiring board, everything is accounted for, and then you will never have a surprise. because process people will take care of the other nitty gritty of the physical fabrication, and you as a electronics designer have taken care of everything, starting with a schematic diagram, making a rat's nest, making a layout, running simulation, and making tools available. Tools in that case are various what you call photolithography devices and drilling and routing, something which manufactures it. And then there are programs which take your programs and then optimize things on large panels. So, I think 600 and 600 seems to be a standard panel. I am not familiar with it. Everything gets done as magic automatically. It is not as big a magic as a scan, okay, or the one inside our heads, but it is still a working magic. In the case of mechanical, what has happened is these files, these CAD files can now be sent downstream for the full manufacture. If it is plastic, you just need to make the part, and then the plastic gets done automatically. In case it is metal, sheet metal, including high power gas cutting is available and laser cutting is available, it gets done automatically, not automatically, with lot of human intervention. Solids, milling is no issue at all. CNC started with actually machining, and now something which some of us are amazed when we see it on a TV, and then little hurt when we get laid off, saying assembly is automatic. So, all these new programs which I had mentioned, they also take care of sequence of assembly and so on, and there are process planning people who take these drawings and ensure you make a robot which makes your car. It is far safer than what you would have assembled yourself. This about summarizes all the lectures and all which are likely to be covered. There are 60 sessions, and then if you go through the things, I am not yet fully familiar with it. Help is on hand, somebody is there, and then the MOOC, NPTEL people have certain requirements and all that, which I am sure they are all at the time of registration and all those things are there. I am not I am not very clear about it, because this thing is only about the technical part of it. However, trying to clarify your any gaps of your understanding, all that help is on hand. So, thank you, and I say welcome to the course. And one small apology I would like to do, I would like to take for you is, first is my whole speech is accented. In fact, in some of the things somebody has written, why does he not speak in English? To me it looked like English. Okay, so kindly I won't say put up with me, understand our limitation. This is the only way I know how to talk, and all of us talk like this. Written, I understand we can do. There is no simple transcription available. Secondly, I have relied heavily on online public resources. So, in a way, while I am not selling or marketing anybody's products, it is retrieved from the internet at the time of it. I am happy that such information has been put there, and if I feel all of you should also do, and in case there are some requirements there, make use of it, and things change. Do not look at what is presented here and then think this is the end. Maybe 2 years or 3 years onwards, many more items, especially connectors and all those standard enclosures, and then various types of programs, all of them keep coming up all the time. So, to sum up, I have a small issue with accented speech. Secondly, I have relied on online resources, which I expect you to do. Thirdly, which is probably final, and I will stop here, all the time new questions are coming, new problems are cropping up. There are no answers, there are no canned answers, but if you do like that, automatically something else will happen. There you need to try and come out with alternatives. Once an alternative has come, then try to work out things until they come into the proper form. And then I think it's time I stop here. So thank you. I'll be looking forward for you for taking this class and then giving whatever benefit out of it. And maybe for a second round we can probably take a feedback and try to see. But the only problem is in making it general we can lose the specifics, and making it very specific the abstraction is lost. I tried to make a proper balance between them. And if you start young, if you do not understand, do not worry about it. If you are let us say somebody who started in first or second year of engineering, this is the right time to start. If you are a school project person, people see your project, will be amazed at it. Where did you get all this? You need not credit me, but it is available for you. So thank you. I will stop here. Bye.